Okay, so in this video, I'm going to be finding the area under the curve of the function f of x that's given right there. Using the limit definition, I don't want to use the fundamental theorem of calculus FTC part 2 because that is typically after we can master this using the limit definition. This is obviously going to be a little bit more challenging, a little bit more time consuming, but this just helps us understand sort of what it is that we are doing to find the area. Again, if you want a better explanation, go to previous video where I explain what this limit definition really is, basically taking the summation of the areas of the rectangles, and then as n approaches infinity, n is the number of rectangles, we would get a better and better approximation. We would get the exact approximation as n approaches infinity, and by doing that, we can find the area under the curve. And so that's the limit definition. Again, that's just the limit of the Riemann sums of the rectangles, the areas of the rectangles. And that's a pretty visual thing. So you can go visualize that in my previous video. So here we're gonna be evaluating this using that definition. So let's do that. So this is gonna be the limit as n approaches infinity. And what we need to do here is we need to take the summation from the first rectangle to the last one, and f of a plus. So if you remember that, this was basically just the limit as n approaches infinity, the summation as I equals 1 to n, f of a plus b minus a over n I times a delta x, or b minus a over n. And this is what we had. So what is b minus a over n? Here we have a and b clearly listed out. So this is just a equals -1 and b equals 2. So b minus a over n, that's just 2 minus -1 over n, which is 3 over n. So that's just a plus 3 over ni. So a is -1, so that's just -1 plus 3 over ni times delta x, or 3 over n. That's just 3 over n there. And what we can do here is now we can take this 3 over n outside the summation. That is allowed. So this is just the limit as n approaches infinity. 3 over n, we can take that out. So this is completely allowed. I equals 1 to n f of -1 plus 3 over n I. Basically, if we have the summation from I equals 1 to n of a times bi, something like this, or a times b plus I, we can obviously take this a and we can bring that outside, and that's completely okay. Okay, so this is what we have. So now what we can do is we can simplify this by plugging this value in for x, because we have the original function. So let's do that. So this is just going to be the limit as n approaches infinity. And I'm going to be writing this many times. Summation I equals 1 to n. And this just is 2 minus 3 times -1 plus 3 over ni. Okay, now we need to simplify. So this is just going to be the limit as n approaches infinity, 3 over n, the summation I equals 1 to n, and then this is just going to be 5, because 2 plus 3, because it's -3 times -1, that's just +3, so 2 plus 3 is 5. And then we have minus 9 over n, so negative, so that's minus 9 over n I. And then what we can do is we can split this up. So the summation I equals 1 to n, if we have like something like 2 plus 5i, or something like this, basically something like this, we can obviously split this into 2 parts. We can write the summation 2 plus the summation I equals 1 to n 5i. We can do this, and this is equivalent, right? So this is just kind of what we need to know, separate from our work over there. So this would be equal to the limit as n approaches infinity, 3 over n times the summation I equals 1 to n 5 minus the summation I equals 1 to n 9 over n I. And you might be wondering why I didn't bring that 9 over n. I will do that on a separate step. So this is just the limit, and we can always bring that out as n approaches infinity, 3 over n. So this is just 5n, so 5n minus 9 over n times the summation I equals 1 to n of I. And to get to this point is the main reason why we did all of this. So here we can use the formula that we know for summation. So the summation I equals 1 to n of I is just equal to n times n plus 1 over 2. Knowing this will help us. So we can just replace this with n times n plus 1 over 2. So this just becomes the limit as, and I should probably do this in white. So the limit as n approaches infinity, 3 over n, 5n minus 9 over n times n plus times n plus 1 over 2. So now we need to further simplify this. Okay. So this is just 5n minus, so this just becomes n squared plus n. So this is just n squared plus n over 2. So this just becomes 9n squared plus 9n over 2n. And then obviously this is times 3, and we have all this stuff here. I just didn't write that, so we can write that first. Now what we can do is we can distribute this in. So this is just going to be the limit as n approaches infinity. I know that I wrote this many times, but this is, you can skip some steps once you have this all down. So this is just 15, because the n's cancel out, minus 27, so 9 times 3 is 27, n squared plus 27n over 2n squared. Okay. So what does this become? I'm going to continue this onwards here. So this is, if we can simplify this further, this just becomes the limit as n approaches infinity of 15 minus, so this n squared can cancel out, so this just becomes 27 over 2, and I should probably do that, 27 over 2 plus 27 over 2n. That's what we end up with. Okay? And as n approaches infinity, this bottom part is just going to become super large. This bottom part is going to approach infinity. It's going to get super large. So this whole thing is just going to approach 0. So what we're ending up with is the limit as n approaches infinity of 15 minus 27 over 2. And this is going to be equal to 15 minus 27 over 2. 15 can be written as 30 over 2 minus 27 over 2, which is just, drumroll, 3 over 2. And that is our final answer. So obviously this took a lot of steps. This was very tedious. This was very annoying. You needed to know the summation stuff. You needed to know a lot of stuff in order to solve this question using the limit definition. But in order to understanding the limit definition before moving on to the fundamental theorem of calculus part 2 is really important. So I hope you found this video helpful and a bit annoying.